I want to do this example question for two reasons. Number one, it's got a different coefficient here for x, okay? So you might get different numbers of solutions than what you might normally expect if it was just a single x. And number two, I plan for this to be sort of the, you know how I try and give you sort of a series of steps. Like, okay, here's what you need to go through. Here's my 1, 2, 3, 4, and then that's how I approach questions like this. I want to use this as the example for auxiliary angle. Okay, now if this is the setup, what's the very first thing that we do if we're going to treat this question with auxiliary angle? Very first thing. Okay, so we want to introduce something, right? Now, obviously this right-hand side is just the number that you're going to choose, okay? So it's not to do with that. It's this left-hand side, right? So I'm going to let that, coefficients and all, be equal to, now, here's where you have to do some thinking, okay? So you've got 4 different forms that you can choose from. Which form are we going to choose? Yep, good, yeah. Okay, I think I heard it a few different places. The first thing to notice is there's a sign out the front, okay? So I'm going to have R, sign. So you pay attention to the order, and then the second thing you look at is the fact that in between them is a minus sign. Okay, so I'm going to pick an expansion here, which will just let me treat A and B as the positive coefficients here. And I don't have to worry about negatives. I'm going to get an acute angle, which will be nice and I don't have to worry about what quadrant I'm in. Okay, so to get a minus for sine, I'm going to have x minus alpha. Okay, so far so good? I probably should have. So those are the 2 things that we're looking for. Okay, now what? Okay, so you got 2 steps. Once you get sort of, sorry, not 2 steps, 2 choices. Once you get really comfortable with using auxiliary angle, you can skip the expansion step, okay? But since I still think we're trying to learn it, let's just make sure we get our coefficients right and match them up properly and expand the right-hand side. Question?
Yeah, do you need to expand like the r squared, sine squared, cos squared?
No. Do you mean the Pythagorean identity part? Is that the part you're asking about? Yeah, okay. The answer is no. I'll show you the amount of working that I would expect. You can go straight to r equals the square root of, etc., etc. But I'll get to that in a few lines. Yeah.
So would you have to do anything with 2x?
Good question. Sorry, probably should have put that there. Does that make it better? Thanks for picking that up. And that'll also affect the number of solutions that we give the thumbs up to at the end. Okay. All right, so do you get your coefficients to match up? I'm going to expand the right-hand side, okay? So over here, I'm going to get r out the front, okay? And this is just my regular expansion. Sine, cos, sine. Okay. So from there, I might just make these coefficients a little more obvious. I'm going to go to r, okay? So I've got my coefficients lined up here, okay? In order to work out what cos alpha and sine alpha are, they're going to have r in them, right? So I might as well work out r to begin with. R is just going to be the square root of a squared plus b squared, right? I'm going to go 3 plus 1. Okay? So since I wrote down straight away that it's a positive square root, that's why I mentioned it has to be greater than 0. Okay? So r is equal to 2. That's good. Now I can bring that down into my 2 equations involving alpha, right? So I can say, let's see here, r cos alpha should be root 3, right? So in fact, I can go straight to this line. Cos alpha is equal to root 3 on 2. See where I got that from? Okay. If you don't feel comfortable quite jumping there, you can say r cos alpha, which is 2 cos alpha, and then have this as the next line. Okay? Either of those are fine. Now, because we picked the form, right? We got to choose between the 4 and we picked the natural form, therefore I already know that my alpha is going to be acute. Okay, so I sort of actually don't need to worry about what my sine alpha coefficient is, but just for the sake of it, just to be sure, you jot down your other one, sine alpha, that corresponds to the 1, right? So that's going to be 1 over 2. And you can see that they agree with each other. If they don't, you've picked your coefficients wrong, or you matched up things incorrectly. Okay. So, alpha is acute. So what is alpha? Radians. Pi on 2. Don't bring me out here. Pi on 6, hooray. Okay. Gives me a real nice warm fuzzy feeling when I see my students getting the right answer. Okay, great. So pi on 6, I've got my r, so now I can rephrase my using this identity and pop it straight into the equation, right? So instead of that left-hand side, I'll say this. Okay, no, sorry, that's just a wonky bracket. Okay, so that was the auxiliary angle part of it, okay? So let's just finish it all off, divide through. So you've got this. Okay, so watch out here, by the way, because you're in 2x, okay, so this domain here, you're going to get, it's going to wiggle many times, right? Or twice as many times as normal. So you're going to get a couple of solutions where you would normally only expect one, right? So this is what sine looks like. Okay, so where's regular sine x? Where's it equal to 1? Well, up here, right? And what angle is that? Pi on 2, right? Okay, but we've got sine 2x, okay? So that's going to repeat again. So you're expecting another answer, namely that plus 2 pi. So that plus 4 pi on 2, so that's 5 pi on 2, right? See that? So therefore, I'm going to note both of these answers down when I come down here to solve. So I've got 2x minus pi on 6 equals okay. So now I just need to tidy up, get rid of that auxiliary angle, add it to both sides. So that's going to give me, let's see, let's become 2 pi on 3. This will become 8 pi on 3. I think, double check that one. Okay, does that make sense? And then I'm just going to divide. Pi on 3, 4 pi. Okay, and I guess I ought to, the reason why I've got these dots here is because I'm thinking in my head there are many solutions to this, but here I'm just restricting it to the 2, so I might as well put in my domain restriction here. Okay, and there are my 2 answers, right? So let's just review quickly what were the steps that we went through. Number 1, you introduce your form, okay? So you got to choose which is the most natural one to make the solution for this question easier. Obviously, as I said before, if they stipulate to you, especially in such a form, you don't have to pick, but you still have to go through these steps here, okay? Then, in here, what's this next step, okay? We're trying to work out our new amplitude and phase. Okay, that's our R and our alpha. We just use this expansion here to equate coefficients. You've done that before. Okay, and then here, finally, you just solve the equation. Okay, which is actually the part that you already knew how to do. There's nothing to do with auxiliary angle here in terms of the methods. And you remember me telling you, the whole point of this method is to phrase a question like that as a question like this, which you already know how to solve, which you learned how to solve last year. Okay.